magnetism is used in our everyday lives. Like, for example, MVP players. Without electromagnetism, these wouldn't be possible. So let's get rid of that one. Alright.
What's up? We're at Denis's house and we're working on a project over electromagnetism. To understand what electromagnetism is, you guys need to know what it is. First, for me, electromagnetism is a magnet created by using electric flow. Electromagnetism has been used in our everyday lives, from lamps to TVs to cell phones and even our MP3 players that Mr. Willie gave us. Magnet fields and magnet forces have been existing for about 2,000 years, even more. But Chinese sailors were probably the first ones to use it over 900 years ago when they used magnets as navigational compasses, or they made navigational compasses to navigate across the ocean. In 1820, it was first discovered by a scientist, a Danish scientist, his name was Hans Christian Ørsted. In his experiment, he used a compass and a wire with electricity flowing through them. In his experiment, he placed the electric wire over the compass and wanted to see what it did. In his prediction, he predicted that the compass needle would point parallel to the same direction as the electric flow. But to his surprise, he noticed that the compass needle pointed perpendicular to the electric flow. So to give you guys a better idea of what this might look like from Hans's experiment, my boy Denis over here holding the cameras is gonna do this experiment for you guys.
What's up? This is my crib, as y'all can see.
It's nice.
This is Denis, the Menace. And we're about to explain to you guys how Olmsted figured out that that when electricity runs through the wire and you place a compass on it, the compass points perpendicular. So as you can see here, we have a lamp, and when we turn it on, there's electricity thrown through it. And as you can see, the compass right now, it's pointing north, which is toward Byron.
Let's see if you can see it. Oh, there we go.
And then when we place the compass over here, as you can see, it changes direction.
Hold on, your hands in the way, move.
Right, let me place it.
There it goes.
So as you can see, this is pretty perpendicular to that, just like Olmsted predicted. Well, not predict, but he saw.
He thought about it.
Class, this is our main experiment right here, showing you guys electromagnetism. Denis in the booth over here is going to show you guys how it works. Alright, all you need for this experiment is a battery, some copper wire, and you wrap it around a nail or some other soft type of like wire. So. Like this. Yep. Like this. And you need a conductor to tie the battery to. And don't mind the jelly beans in the book. They're just to keep the wire from moving around when I'm doing the experiment. Those are my jelly beans. Alright, keep going. Yeah. Sorry. This mom's gonna get mad. No, she won't. Alright, what you do is you just tie these here. Hold on, let me get a better angle. Bro, check this out. Alright. There you go. And then take the nail, and as you can see, picks the other types of iron up. Let me see. Right now we got staples right here, and he's picking up the staples with the nail. There we go. There you go. Perfect. Ooh, it's running out of battery. Yeah. We can predict the magnetic field on this by using the first hand rule. And what the first hand rule said is you take your thumb and you line it up where the electricity is running, which always runs from positive to negative. So in this case, positive being coming from this way. And you put your thumb here, and the way where your fingers are at, that's where the electricity is. electricity flowing through the wires, which create an electric force, which then turns this into a magnet. So right now, there's electricity running through them, and the door stays open. Let's say there's a fire alarm, something went off. So the electric current shuts off, and the magnet doesn't even work no more. So then the door closes.
Well,
right now, I'm about to explain to you guys a little experiment about how our Earth is a really, really big magnet. Alright, this is how the experiment goes. Well, I got drawings, but still. You hang a magnet, as you can see from the picture, from the ceiling, with your north end of the magnet and the south end of your magnet. Now, after a while, the north end of your magnet should align, as you can see in this picture, should align with the North Pole. Alright, but since the North Pole and the North End, they can't, since they attract each other, that technically means that your North Pole is really your South Pole, because opposite poles attract each other. Vice versa with the South Pole and the North Pole.
I first showed you how Earth can be polarized a second ago, but also scientists have found at the bottom of the ocean floor, they've found rocks that have irons in them, and the rocks, they're not aligned in the same way. So this means that Earth does have poles, and the poles, they also have changed during history. They have changed many times. So the North Pole has been the North before, and the South Pole has been the South before.
After school, try to make our last minute touches on our project. Right now, Dennis is going to explain one of our experiments to you guys.
Alright, so this is a simple experiment. We have a magnet over here, and this is like a closed container that has some liquid and iron fields in it. This is going to describe the magnetic fields in the magnet's way. So we're going to put the magnet in there. As you can see, the iron fields, they start to get drawn towards it.
Here. Put it back down. Yeah,
Towards it, and they run in a circular pattern from north to south. So not in a straight pattern, as you can see there, from north to south in a circular pattern. Alright, now my boy Byron is going to show you guys how it's done.
Alright, Dennis. Alright, well, since you can use electricity to create a magnet force, you can also use magnet force to create electricity. This right here is these 3 copper wires that are wrapped up in a circular, or whatever, circular shape. And all you do is stick your magnet, and you go in and out. And this right here measures how much electricity
It's being produced.
how much electricity is being used. And each time I go down, you use a bigger circle.
As you can see the needle.
The needle gives off a bigger, so and I stick in the largest one, and there you have it, biggest one.
This little guy is this cool machine. So you can talk to him about that. We
Yeah.
could have, we're so good, we could have, but Mr. Little, no, Mr. Willie.
I mean, I already know I'm smart. I got a 99% on all my tests. So.
For sure.
Yeah, I knew that. Yeah.
Well, let's get ratchet. Look at her, prettier than Hanny and thicker than Janet. She say she like all of my club bangers, I be jamming. Told her to bust it open, let me see what's really happening. She the ship and I'm the captain. I'm the captain, booty bigger than the Pacific Ocean, that make me happy. And I'm all the way in your city.